then you can pick it up. It is also a prism because it has the same cross section along its length. When we have explain what's a prism now. A prism is something that has the same cross section. What is the cross section? It's the front here. Along its length. So it does not decrease at no point in time. It does not decrease. Let me show you another prism. This is another prism. And how many sides this has? 1, 2, 3, 4, 5. And a 5-sided figure is called a, what do we call it again? No, in terms of shape. What polygon do we give to 5 sides? Pentagon, right? So this is called a pentagonal prism. And notice, it has the shape of a pentagon straight through. As in the pyramid, it just decreases as it gets to the vortex, right? Now, it has how many vortices? Just like a cube, right? At each vortex, how many edges meet? 3, same thing. So make a quick jotting of this, and let's see what we can do next. Alright, let's continue. So we are all finished, right? So imagine if I had a cube, right? Let's look at cube and cuboid since we're on that topic today. So imagine I have cube or cuboid. And I made this cube or cuboid. Or somebody give it to me. But I decided I'm gonna open it up. Close it up. Flat. At the top of that, what shape will I get? Or what name will we give to that? Right? If you open up any solid, or let's say a cube, if you open it up, so we have something flat. What are we going to get? Or what name do we give to that? So we don't have a 3-dimension anymore, we have a flat something, a shape of it. 2D very well. So there's a name that we use for that, and that name is called the net. Net of a solid. So the net of a solid really is when you open out this 2-dimensional, right? Sorry, when you open 3-dimensional to get a 2-dimensional, right? So for different solids, for each solid, we can have different nets. But they can all fold up back to give us the same solid. So for instance, a cube, you might not have one net for a cube, you might have more than one design of it, or putting it, right? So let's imagine if you open a cube, what would it look like? You notice I have two models here. So what I did, I put a picture on my slide here for both cube and cuboid, and then I make a model of it. So I'll pass it around, you can fold it up and you can actually see what it looks like. But bear in mind, I just made one for these, right? So let's look at the cube first. This is what the model will look like. So if we fold that up, we're going to get the cube. We follow, so let's look at it. I don't have the color like that. Just bear with me, right? So look what happens here. I can fold this like this, isn't that so? Then I can fold like this. Right? Just weird, right? Okay, just help me. So I can fold this like this, and you see what I'm doing there? And I have a cube there. See there? Somebody give me the cube, I open it out back. What do I have? The net, which is the 2D. This is one way. Bear in mind, you can have different ways of getting the same, right? Let's look at the cuboid now. What will the cuboid look like? The cuboid will look like this, right? So let's fold this up and prove to you that we can get a cuboid. So I have it me there, I have it me there a cuboid. See there? See how the net is used to fold up? Bear in mind, for each cube, for each solid, there are different models of net. So there's not one way you can draw the net. So what I mean is there are other ways I can draw it and fold it up to get the same cuboid. So these are all the nets. I'll pass it around and you're going to work in groups and you're going to just have a feel of it. You just pass it around. No, fold it up and then pass it. So work with the person next to you. And notice how they fold it up and they get the cuboid, isn't that so?